Now, this is a worksheet on calculating the numbers of bacteria growth after some time of incubation. Incubation means when you put a bacteria in a petri dish, you put a bacteria in a petri dish, then you put in an incubator for incubation to take place. During the process of incubation, what happens is the bacterium divides into two. So, but what happens is this bacterium divides into two after every 20 minutes. That is to say, every 20 minutes you're going to have binary fission taking place. We call it binary fission. Binary fission is a process by which bacterium divides. I mean, it's a reproduction process in bacteria. So now the question says, how many bacteria are we going to have after 1 hour? Now let's move on to the next slide to see how to solve it. Now the question says we have one bacterium, and the bacterium divides after every 20 minutes. After every 20 minutes, the bacterium divides. So we want to know what the number of the bacteria will be after 1 hour. The first thing to do is, because we know the division takes place after every 20 minutes, so we should try to convert this to minutes. So 1 hour times 60 is going to give you 60 minutes. So the meaning is we need to find n, the number of times. We need to find the number of times the bacteria divides. We need to find the number of times the bacterium divides. So divides means the number of times it reproduces. So if you want to find that, since we say the total number of time that the incubation took place is 60, so the total time is 60 minutes. And it divides after every 20 minutes. So how many 20 minutes can we find in 60 minutes? We divide it by 20 minutes. And that's going to give you 3. So the meaning is the number of time which is represented by n is equals to 3. So that is to say, the bacterium would divide 3 times within 1 hour. That's good. So the next thing to find is we have a way to find the answer. We need to remember that we have what we're looking for is the final number of the bacterium. We represent that with F. And I will represent the initial number. The initial means the number in the beginning. The initial number of the bacterium is represented with I. So knowing F, I, and N, we can now write out the equation. The equation is F equals to I times 2N equals I times N raised to the power of 2. I think I'm getting that wrong. Equals to I times 2 raised to the power of n is correct. So this is the formula for calculating the final number of bacteria. So remember this equation, please, everybody. F equals to I times 2 raised to the power of n. Now, since you've been able to know the value of F, no, we don't know that, that's what we're looking for, but you've been able to know the value of I. The value of I is 1 because in the beginning we said 1 bacteria. And the value of N is 3. So it's very simple plugin. The values you've got f equals to 1 times 2 raised to power of 3. So f is going to give you what? 1 times 8. And f is going to give you what? 8. So it means the final number of the bacterium after 1 hour is 8. The meaning is the bacterium doubles after every 20 minutes to become 8 bacteria after 1 hour. So the same thing applicable to if it's 2 hours. If it's 2 hours, the same thing we need to do is we convert the 2 hours to minutes. It's going to give you 2 times 60. It is going to give you 120 minutes. So now we want to know the number of times the division took place. So that's going to be 120 minutes divided by 20 minutes because we said it divides after every 20 minutes. So this is going to give you, when you divide this, it's going to give you 6. So n equals 6. As we all remember, I is 1 because that was the initial number, and f is what we're looking for. Remember your formula, f equals I times 2 raised to power of n. The reason you're having 2 is because the bacteria divides into 2 after every means in binary fission. Binary means 2. So fission means dividing. Fission means splitting. Something splits, it fuses. When it comes together, you say it fuses. But when it splits, you say fission. So this is the reason why we're using the 2. So now you say f equals the I, which we know to be 1, times 2 raised to power of 6. F equals to 1 times 2 raised to power of 6 is 64. F equals to 64. The final number of bacteria we're going to have after 2 hours is 64. So I think with these few examples, you can pause the video and work out for the 3 and 5. Now let's do for 3 and 5, where it's 3 hours. What is going to happen is same method. You say 3 times 60 is going to give you 180 minutes. That means the number of time which the bacteria spent in the nitrate agar is 180 minutes. And you want to find n, as we all know, the number, the bacterium divides into 2 after every 20 minutes. And after 180 minutes, how many divisions are we going to have? So that's going to give you 9. You're going to have 9 divisions to take place. So it means the meaning is n equals to 9. So since we've got n to be 9 and I is still 1, then we're looking for f. The same equation. F, which is the final number of the bacterium, is I times 2 raised to power of n. Remember, please, f is going to give you I is 1 times 2 raised to power of 9. If you don't know, if you don't have a calculator to solve this, you can just say f equals to 2 raised to power of 9, because 1 times 2 raised to power of 9 is 2 raised to power of 9. But if you've been fortunate to have a calculator, then you should do it by saying 2 raised to the power of 9 is equals to 512. So meaning you're going to have 512 bacteria in 180 minutes, which is 3 hours. Now the last one, which is 5 hours, is the same method. For 5 hours, you convert the 5 hours to minutes times 60. 5 times 6 is 30, which is going to be 300 minutes. Now the next thing to do is you want to know the number of times the division took place. So to know that, you say n is equals to 300 divided by 20 minutes, because I said the bacterium divides after every 20 minutes. So 300 divided by 20 is equals to 15. The simple mathematics, 15. So the meaning is n equals to 15. So then you know I is the initial number of the bacterium, which is to 1. And what we're looking for is F. So write out the equation F equals to I times 2 raised to the power of n. Then you close the bracket. So your F is equals to 1 times 2 raised to the power of 15. So if you don't have a calculator also, if you find it difficult to get a calculator, just say F equals to 1 times 2 raised to the power of 15 is 2 raised to the power of 15. But if you have a calculator, you should say 2 raised to the power of 15, 2 raised to the power of 15, 2 raised to the power of 15 is equals to 32,768 bacteria. So this is a very simple mathematics, and I wish you really enjoyed the video. Thanks for listening. Bye.